since we have already finished discussing all the properties that are involved in solving differentiation or derivatives, let us try solving these examples that you can see here. So the instruction here is to simply find the derivative for each number. Now, for the first one, we have y equals 45. 45 is a constant, so when we want to take the derivative, that is simply equal to 0. So this is the answer for this problem. Okay, so number 2, we have, now this is the expression, and then this is actually taken from all your modules, and the one in your module is actually not multiply, it is not in superscript, so there is an error in converting the file, so bear with it, but this is actually what should be written there. Now it says here that there's something like at x equals 1. What it means by this at x equals 1 is that you need to find the derivative of this function and then substitute this value of 1 to that derivative. So in short, this simply means that if we take the derivative of this function, you'll have to substitute 1 to that derivative. So this is what we mean by this at x equals 1. So f prime of 1, that is equal to the derivative of this one. So we get 36 times 2 is actually 72, and then x plus 74, and then this one is 0, and then you substitute the value of 1 for x. So what we have here is f prime of 1, that is equal to 146. So the answer here is 146. So as you can see here, the answer here is a real value number, simply because we have given the value of x. So if there's no something like at x equals 1 here, you'll only be finding f prime of x, that is equal to 72x plus 74. Now for the next number, we don't have any value for x, so let's just find the derivative. By the way, we're using all the Lagrange Lagrange notations here. So g prime of x is equal to, since this is the square root of 3x, you can rewrite this as 3x raised to 1/2 and then do our general power rule. So we have here 1/2 and then 3x raised to 1/2 minus 1, that is negative 1/2, and then multiplied it with the derivative of what's inside, so that is times 3. So don't forget to differentiate 3x because this is actually applying chain rule. So we have 3 here, and then for the next one we have 4x. So the derivative of these would be equal to 3/2, and then 3x raised to negative 1/2 plus 4x. This is already answered. You can rewrite this something like 3/2 and then square root of 3x. It can be written something like this, and then plus 4x. So any of these will do. So for the next one, so if you're finding this very fast, then you might as well want to pause it or go back to our previous lectures about the stuff that is happening here. Actually, we already discussed this before when I was explaining the properties of differentiation. So number 4, y equals 2x plus 4 and then x squared minus 1. Now there are ways we can solve this. The first one is to simply take the derivative of this one by applying the product rule, and the other one is using some FOIL method and then just do the derivatives. And the first one is the best option since you don't have to like expand this. Okay, but if you want to expand, then it's all up to you, but I prefer the one using just the basic the properties that are very evident, because as you can see here, we have something like f of x for 2x plus 4 and then g of x for x squared minus 1. They are actually multiplied, so we'll be doing a product rule here. So we get 2x plus 4, just copy it and then multiply it to the derivative of this portion, so that is 2x, and then add, since this is a product rule, so we copy this second term and then multiply it to the derivative of this first term, so we have 2. So we have y prime is equal to 4x squared plus 8x plus 2x squared minus 2. And then we combine like terms, so we have 6x squared, then plus 8x minus 2. So this is the answer for this problem. Okay. So now we move on with number 5 to 8. So as you can see here, in number 5, we have a rational expression. So what we have to do here is to apply the quotient rule. So we have y prime is equal to the denominator multiplied with the derivative of the numerator, that is 1, and then subtract, copy the numerator, and then derivative of the denominator, so that is 2x. Then divide this all by the square of the denominator. Some students call it the low the high minus high the low over low low. So if that's what suits you, then go for it. So I'll just be simplifying this. So we have minus 2x squared and then plus 6x divided by x squared minus 1 squared. So y prime would be equal to, can we combine? Yes, we can combine these like terms here. I'll just be writing 6x at first, since it is the positive one here. And then minus 1, and then minus x squared. Then divided by x squared minus 1 quantity squared. So this is your final answer. I hope I don't mess up this next problem for that. So number 6, what we have here is a trigo function, wherein the function inside is 2x, and then it says here that x equals negative pi over 2. So we can simply something like represent this as f prime of negative pi over 2. So it's something like this. Okay, so I used f instead of y, since, well, basically y translates to f of x, so, a function with respect to x. So in this case, I'll just be having this y prime, so that is equal to the derivative of this function. So since this is co, we have a co there, so you just have to like put a negative and the negative sign, and then 2x, and then the derivative of 2x would be positive 2, so it is multiplied. And this is the derivative of that. This is actually equal to negative 2, and then sine 2x. And then you substitute this value for that. So y prime is equal to negative 2, and then sine of 2 times negative pi over 2. So y prime is equal to negative 2, and then sine. So this will be sine of negative pi. So when we take the sine of negative pi, that is actually something like the negative x-axis if we're referring to the Cartesian coordinate plane. So in this case, this negative pi would be 0, since we take the sine of that, since sine is the value of y for if you're considering the Cartesian coordinate plane. So in this case, that will be 0. It would have been negative 1 for if it is cosine, since cosine of negative pi is, cosine of negative pi would be equal to negative 1. So the answer would be positive 2 for if the problem here is in cosine. But of course, since it is in sine, so that will be 0. So let's move on with this next number. So we have p of a is equal to 3a squared tangent a with respect to a. So this with respect to a is very important, since I am referring to like differentiate this function with respect to a. But of course, when you can see here a, sometimes it is always almost given as if you need to differentiate with respect to this a, since it's just the variable that is here. But it is very important when there are a lot of letters here and there's no specific instruction into what particular variable you'll be differentiating. So we have there with respect to a, so we get p prime of a, that is equal to the derivative of this function. So this is actually a product rule. We have 3a squared and then tangent a. So I'll be taking 3a squared and then the derivative of tangent a, we have secant squared, and that is a. And then actually you still have to differentiate a, but differentiating a would be equal to 1. And then you add tangent of a and then multiply it with the derivative of 3a squared, which is 6a. So that the answer here would be p prime of a is equal to 3a squared secant squared of a and then added with 6a tangent of a. So have the habit of including the parentheses for representing the function that is inside of a what called the trigonometric function, since it might get confusing in latter portion if you're just writing like tangent a, secant a. So this one again, we also have different letters here, but it says here that we need to differentiate this with respect to t. So you're like assuming that t is our x and then v is our y. So in this case, I'll be having the derivative of v. If you're actually finding it difficult, you can actually substitute this with x and then use this as y. And that way you won't be having, or f, and that way you won't be having difficulties in differentiating. But of course I don't recommend it, since you have to learn that there are a lot of letters of use in expressing differentiation, and I mean it'll be very time consuming for you to replace all of these letters with x and y. So derivative of this would be, so this is just the power rule, so 48 times 2 I think is 96, and then t, so we subtract 1 from the exponent, and then this one is just 65, we drop t as 1, and then this one is a trigonometric form, so remember the derivative of that is secant and then tangent. So secant tangent of whatever is inside this, and then you differentiate what is inside, that should be 1, so I won't be writing it. So that is the answer for this, number 8. Okay, so now let's move on with the next. So for number 9, actually this 1 to 10 are really very easy problems, and starting from 11 to 15 will be quite confusing. Okay, so we just need to take the derivative of f of x, that is f prime x, that is equal to, this one is actually a trigonometric function with quotient rule. So we copy the denominator and then find the derivative of our numerator, so we get cosine of 4x and then multiply it with 4, since this is a chain rule already, and then subtract it with our numerator multiplied with the derivative of our denominator, and then we multiply this. Now the derivative of our denominator is actually a product rule of sine 2x and cosine 3x, so with that will be a product rule, so we get sine 2x and then multiplied with the derivative of this one would be negative sine of 3x times 3, and then plus cosine of 3x and then multiply it with the derivative of sine, which is cosine 2x and then times 2. And then since we're just done with our numerator, then we divide all of these. I think that's not a straight line. Oh, it is. Okay. So we just have to square our denominator here. Okay. So we can now simplify this. This is a very long equation, but oh, I'll let me just dissect all of these. Okay. So we started with um this equation, which we started from the product rule. So we just have to copy this. This is our something like the g of x, and then this one is our f prime x. So as you can see, this is our f of x, this is our f of x, and then this one is our g of x. So in this case, this is the f prime x, and then in our product rule we get 1 and then minus what we have there is f of x, so we just have to copy this f of x and then take the derivative of our denominator, which is this is the g, this whole term here is our g prime x. This is a very long answer, since remember this denominator is actually still in product rule, so we have to apply product rule here, and then something like we have this g of x. When we try to name this, let's say we have h of x and then j of x. So as you can see here, I did a product rule, so this is h of x and then this is the j prime x, that is the derivative, and so on and so forth. So in that way, we're actually doing two major rules in trigonometry at the same time, and then we just have to square it. And it's not yet done, by the way, since there is still this plus 38x, so we just have to add 38. So that is our answer for this problem. So I would love to simplify this further, but I actually lack of space, so let's just leave it like that for a moment and try to do it at your home to simplify it. I think you'll be able to never mind, you can cancel them out. So yes, that's our answer. So we move on with number 10. So since we're already crowding here, let's try to move this number 10. Somewhere here. Okay. So for number 10, this is also a quotient rule. So we get y prime, that is equal to the denominator again, so that is our denominator, and then multiply this with the derivative of our numerator, so we get 1/2 x minus 5 raised to negative 1/2. And then you still have to take the derivative of x minus 5, but that's just 1, so I will not be writing it anymore. And then subtract this with the remaining of the product rules, the quotient rules, so we get square root of x minus 5 and then the derivative of our denominator. So this is something like the sum and difference of three terms. So we will be differentiating them one by one. So the first one, for square root of x, we have 1/2 x raised to negative 1/2, and then for 3 we have plus 3, and then for x squared we get negative 2x. So that's it for our numerator, and then we divide this by the square of our denominator. So that's it. You can actually do some simplifying here. If I had a lot of space, I would have done that to our trigo, but we lacked it, so it's a shame. So anyway, so we have here 1/2, but not all the time I will be able to like simplify it, since like for this example, I can see that we can no longer do anything about this. You can just rewrite this in a more beautiful way of writing. So we get 1 over 2 square root of x, and then plus 3 minus 2x, and then divide all of these by the square. You know, your skill should be focusing on differentiating and not actually simplifying, but well, simplifying will also give you some edge, probably. I'll just be taking out, oh, I actually did something wrong here. This should be, since this is negative, it should be placed under some 1 over, since it is negative, okay? That's why we can no longer simplify this further. Well, we can rationalize this and multiply this by the value, but I won't be doing it anymore, so let's just leave it something like this. Well, let me just do this once, okay? So we have 1/2 and then times. We rationalize this, what we get here is square root of x minus 5 over x minus 5, and then we have square root of x plus 3x minus x squared, and then subtract this with square root of x minus 5, and then 1 over 2 square root of x plus 3 minus 2x, and then divide all of these by the square. Now, as you can see here, we have square root of x minus 5 and then square root of x minus 5 here. I can actually factor them out, but I'll be having this 1 over x minus 5. So, if we want to use some LCD here, we can multiply this with x minus 5 and then divide all of these terms by x minus 5. So what I'll be doing will be something like this. So we have 1/2, and then that is square root of x minus 5 over x minus 5, and then that is square root of x plus 3x minus x squared, and then subtract this with square root of x square root of x minus 5, and then times x minus 5 divided by x minus 5, and then 1 over 2 square root of x plus 3 minus 2x, and then divided by square root of x plus 3x minus x squared, quantity squared. In this case, I do have something like square root of x minus 5 at the denominator, so I can pull it down here, this x minus 5. So I'll be left with 1/2 square root of x minus 5 square root of x plus 3x minus x squared, and then that is minus square root of x minus 5 times x minus 5, and then 1 over 2 square root of x plus 3 minus 2x, and then divide all of these by x minus 5, and then square root of x plus 3x minus x squared, and then square. So you can actually factor out square root of x minus 5 here and then distribute this, but as you can see, I'm fine with this answer, and don't forget to write y prime here. I'm fine with this answer, and as well as even at this point here. Where is that? I'm actually okay with even this one, because I'm much more concerned with how you differentiate and not how you simplify. So I'm fine with this even if this is just your answer. I just need to see what happens with each term, okay? So in each step, you'll be having some kind of simplifying in this portion, but I'm fine with any of these variations of the answer as long as it's correctly simplified. Okay, so that's number 10. As you can see, we're getting quite a longer answer as we move on with the numbers. And now let's have some break first. Let's have this at number 11. So number 11, we have to take the derivative with respect to x. So we have the different letters here. We have e, so we would assume that this is a constant. So the derivative, the answer here would be equal to, since we'd assume this one is a constant, so that will be e times e raised to x, and then e minus 1. And then we add plus. So since e is a constant, so if we would be assuming that this is any value that would assume a constant value, cosine squared of any value that is constant would be a constant. And by that, the derivative would be equal to 0. So in that case, we're only left with e times times x, e raised to e minus 1, or e squared x e minus 1, and then don't forget to write dx, since we're actually using the Leibniz notation here. So don't forget to write that one. So the next one would be number 12, pandemic. Actually, should not be read as pandemic since we don't read something like that in mathematics. That should be the derivative of c, the derivative of pandemic with respect to c. So the operation for these letters are just multiplication, and all we have to do is to simply differentiate it with respect to c, assuming that all of these are constants. So with that, if these are constants, then based on our constant multiple rule, you just have to leave the constant and then differentiate what is the variable that should be differentiated. Differentiating this would just be 1. So you're just left with pandemi, and then you write dc, since that is the derivative of our c. So this is the answer for this problem. Okay. So the next one, number 13. By the way, all of these letters that we have that you can see here, we're just actually extending the property of our constant multiple rule. So don't be intimidated with all these letters. It's just like it's a number. So imagine this is just like 1 times 2 times 3 times 4 times 5. So if you multiply all of these numbers, you'll get a certain number and then a c here, which is 1. So if this is expressed in something like y equals, then this dc will be you remove this dc and you'll be left with pandemic. So since we're using the Leibniz, then you should add this dc. Now let's try doing this. Number 13. It looks more complicated, but let's see. So what we have here is a derivative of f of g of x, which is a composition function. So remember, your composition function is actually the application of chain rule. So you take derivative of this function in such a way that you take the derivative of f prime given you have g of x on the inside, and then you multiply it with the derivative of x. So if you will be following this rule, what you have to do is to take the derivative of f and then substitute the value of g of x to that derivative. So in this case, the f prime g of x would be something like 3, since that is the derivative of our f of x. So f prime of x is actually equal to 3. So you just have to take the derivative of this original function that we have, which is equal to 3, and then substitute g of x if there is an x here, but we don't have any, so we'll be left out with 3, and then multiply that with the derivative of our g of x. And the derivative of g of x would be I don't think it fits in here, so let's just do it here. So we just have to multiply this with the derivative of our g of x. So in this case, it's product rule with some trigo. So we copy the denominator. This is multiplication. then take the derivative of this secant squared x. So what we have here is power rule with trig function. So we have 2 times secant of x. So we subtracted 1 from these two. And then take the derivative of secant x, which is secant x tangent x. So that's it for the numerator, for the first part. So we already have g of x, f prime x, and now we proceed with the second part of our differentiation for the numerator. So we get so we copy the numerator and then derivative of the denominator. So we get cosine of x plus secant squared x, and then divide that with the square of the denominator. So the answer is this long equation here, long term here, obtained from the product rule and then multiply it with 3. So that's the answer, and then you add some dx, don't forget it. Okay, so let's move a little here. So this is the answer for this problem. Okay, so now we're done with the last two of our problem. So I think we need to move it somewhere. So let's move it right here. That's the last one. I think I'll be moving that to somewhere here. Okay, perfect. So number 14, we have to take the derivative of this one, and this one will be also a long one since we have here a product rule. So we just need to copy the denominator and then multiply it with the derivative of our numerator, and this is a very an evident composition of function that we have 1, 2, 3. So we have 3 composition of functions, and we'll be taking that individually. So if you have a composition of function, as what I've mentioned before, you do that from the outside going to the inside. So the first one would be sine. So the derivative of sine is cosine, and then just copy what's inside. So that is cosine of sine of x. So you just finished the first sine here, then you be doing the next one, cosine. So you multiply this. You're not yet done. You multiply that with the derivative of the cosine, which is negative sine. So that is negative sine of x, and you just did this portion, cosine of sine of x, and then finally you will be doing the last, which is the sine of x. So that is multiply it with the derivative of sine x, which is cosine of x. So that is how it goes for our first term in the product rule. So this is actually our g of x, and then this whole thing here is a derivative of our f prime x, given that this one is the f of x and this one is the g of x. Okay, so in short, this is the derivative of this function at the top. So now let's continue. So we continue minus, so we just copy this numerator, so sine of cosine of sine of x, and then multiply this with the derivative of our tangent squared x. So the derivative of tangent squared is simply, since this is tangent squared, you will be having this power rule, so you'll be having 2 and then tangent x, since you just subtracted 1 from this, and then you take the derivative of tangent x, so you'll be having there secant squared x. Okay, so this will be divided by tangent to the fourth x. So this is your answer for number 14 given. Actually, this is not included in your module. If you're finding these things difficult, since probably you will just get started learning this chain rule, inform me through your representatives so that I can probably decrease the difficulty of the given that that we solve. So anyway, we're down to the last number, so we get the number 15. While you're watching this, I actually assume that you've already solved some problems from your consolidated module that I gave you. Well, never mind. So let's just solve this, since I've been telling you to solve that for your practice, since I usually give more complicated items for you to familiarize yourself with how this works. So in any way, we have the Lagrange notation for h of x or h prime x. We need to take the derivative. So this is a composition function. As what I've mentioned before, you look at the outside going inside, and on this outside we have 1/2. So remember, this is an exponent of this term. So we're having something like, if this is a f of x, that is raised to 1/2. So what you have to do is apply the general power rule, which is we take the derivative of this f of x raised to 1/2, that will be 1/2, and then it says here that you just have to copy what's inside, so just copy here, so we have 1/2, and then secant, so 1/2 secant of 3x plus, so whatever is inside, just copy it, and then subtract 1 from here. So what we did was doing the general power rule, but it doesn't end the solution doesn't end there. Since we did something like general power rule, we need to take the derivative of this function that is inside. So with that, we multiply this with the derivative of this, so we get, this one is secant, so the derivative of secant is actually secant tangent. So you get secant, but it's not x. You need to copy what's inside, so forget the x. We have 3x plus cosine of x squared here, and then that is secant, and then we add some, not add but multiply, since that is secant tangent. So I prefer not saying x, if you can notice, because it's not always x. Sometimes it is like this, so you don't have to like secant x tangent x. That's not the proper way. That should be secant 3x plus cosine x squared and then the tangent. That's why I don't always say x. Well, we just differentiated the secant of whatever function is here. Now, do you think it's done? So not yet, because we still have to multiply this with the derivative of what's inside. And the derivative of what's inside is, actually that is, I will be zooming out this so that we can have more space better. So we need to differentiate this to finalize our equation. So we have the derivative of 3x, which is 3, and then plus, this one is cosine x squared. So we differentiate cosine, that is negative sine, and then x squared. But you still have to differentiate this x squared and then multiply it with this, so we get 2x. Okay, so I think that ends our derivative, so we just have to rewrite this in a more pleasing way. So I will try my very best to make this narrower. And then multiplied with a secant. Well, if you're wondering if I used to solve something like these long problems when we had these face-to-face classes, the answer is actually yes. We did something like a lot of problems that are very long. Sometimes it consumes the whole whiteboard. But the most difficult part in this online class that I can see, I couldn't see all of you, so I have no idea if you still can understand what I'm doing here. That's why asynchronous learning is the best for those who don't have like a very good or stable connection, but it is actually difficult for when the topic is so confusing that you have to like ask the professor for this. Anyway, so we're done with this problem. So that's all. That's 15 numbers. Took a lot of time for us to solve, but as what I've mentioned before, if you're finding this like this is too much to take, just ask your representative, and I'll be giving some video which is much less difficult than this. Okay, so thank you.